Thanks, so yeah, I will do 7, yeah. There are 16 discs in the board game. 5 blue, 3 green, 6 red and 2 yellow. I'll just do that. It means I can access it easier than reading when I look up. 4 discs are chosen at random. What's the probability that the 4 discs are blue? Okay. Now, remember, it's probability, so I need to find out how many different ways they can be chosen. It's a bit like a football team again, isn't it? The order they're chosen in doesn't matter. Do you get what I'm saying? So we're using the C function, not the P function. So what we're going to do is we're going to do 16 C4. There's 16 discs, choose 4 of them, and that is a total of 1,820. Now, in this scenario, you're only allowed to choose all blue. So how many blues do we have? 5 choose 4 is 5, and that's 5 divided by 1,800 and sorry, the answer is 5, and then the probability is 5 divided by 1,820, and what's that? 1 over 364. Are we all cool with that? Okay. Alright. You open one more window, just one. Should do the trick. Alright. The 4 discs are the same colour. Alright. Same colour. What does that mean? That's all blue. What's all red? Can we have all red? We can't have all green and we can't have all yellow. So we're only talking about all blue and all red. Is that correct? Okay. All blue and all red added together is how many different permutations? Sorry, it's 5 and what's the other one? What's 6C4, anybody? Really quickly. What? 15. So would you agree that that's 23 over 364? Or sorry, 20 over 364?
Yeah.
And what's that breakdown into fraction wise? 1 over 91. Yeah, 1 over 91 is perfect. Thank you. Oh, sorry, yeah. Sorry, the total number of permutations is 1820, so it's 20 over 1820. Yes?
Why do you put your answer over
1820? Because you asked for the probability. You're not asked about how many ways you can do it. You're asked for the probability that will happen. So you have to put whatever, you have to divide it by the total number of combinations. Okay? All 4 discs are different colour. Okay. That's not as bad as it looks. Why? Can anybody tell me? It's one take away the probability of all 4 discs are the same. So what's that then? 1 take away 1 over 91, is it? Oh, sorry. All 4 discs are different colours. Sorry, I'm interpreting that wrong. It specifically wants blue, green, red, yellow. Sorry, I'm interpreting that wrong. So, what it specifically wants is one of each type. Is that alright? 5 choose 1, 3 choose 1, 6 choose 1, and the last one 2 choose 1, and you lob all that calculator and you get 180. But that's how many different ways it can happen. Now we're going to do 180 divided by 1820, and we should get an answer of 9 over 91. Is that alright with you guys? Finally, 2 of the discs are blue and 2 of them aren't blue. It's easier than you think. Okay? Alright, Connor, let's start off with 2 discs have to be blue. What should I use for 2 discs have to be blue?
5 choose 2.
Yeah, there's 5 blue discs and you're going to choose 2 of them. Now the next 2 can't be blue, so what does that mean?
5
So how many discs are left? There's 16 of them, yeah? And how many of them are you not allowed to choose because you don't want them to be blue? Huh? 16 take away 5. There's 11 discs that aren't blue and you got to choose 2 of them from it. So you multiply the 2 then by each other and what do we get? 550. Then the probability of this happening is 550 divided by 1820, and that is 55 over 182. All good? Awesome. Alright, any questions? I'll pause here. Okay. In an examination, a candidate is required to select any 7 questions from 10. In how many ways can this be done? Okay. 10 questions, choose 7. And 10 questions, choose 7 is 120 ways. How many selections can contain the first and second questions? Okay. If we have to select those 2 questions, how many questions do we have to select? Another 5, isn't it? We have to answer 7 questions in total. And we've already answered 1 and 2, correct? So if you were to write it down like this, you've already selected 1 and 2, which means you have 5 questions remaining. And how many are there? What? So 8 choose 5, yeah? And 8 choose 5 is 56 ways. Are they looking for the probability or are they just looking for how many selections? So they're not looking for the probability. Right, happy days. 56. Now calculate the probability that the candidate selects both the first and the first. Oh, the probability, yeah. That's not bad. So there's 56 selections had 1 and 2 in it. How many selections was there in total? So what's 56 divided by 120? 7 Is that what you got, Mick? Yeah. Alright, good job. Now, at least one of the first 2 questions. Okay? At least one of the first 2 questions. So what should we do there? Alright, so 1, take away the probability of both of them. Take away the probability of... Oh, wait. I think that's it actually. Because you're allowed question 1 only and you're allowed question 2 only. So it's 1 take away the probability of both of them. So what do we do there? Anybody? 1 take away 56 over 120. What's 1 take away 56 over 120? Could be wrong with this stuff. Sorry, just give me a sec. Oh, sorry. I'm wrong there. Both of them qualifies for at least one of them, so that's wrong. It's 1 take away the probability of neither. Potato. Neither of them. So yes, Brian? Yeah. Alright, neither of them. Right. So what selections do we have for neither of them? You're not allowed to select 1 and 2. So what does that, how many are left then? 8. And you still have 7 questions to choose from, don't you? So what's 8 choose 7? 8. That's 8 selections out of a possible 120. So it's 1 take away 8 over 120. And what's 1 take away 8 over 120? 14 over 15. 14 out of 15 selections will have at least question 1 or question 2 in it. Alright? Pause it there. Any questions about that one? Class of 16 pupils consists of 10 girls, 3 of whom are left-handed, and 6 boys, only one of whom is left-handed. Alright, so I'm just gonna might just draw myself a little grid here. 10 girls, 3 lefties, 7 righties, 6 boys, 1 left-handed, 5 right-handed. Okay, 16 in total. Alright. Now, 2 pupils are chosen at random from the class to act as prefects. Calculate the probability that the chosen pupil will consist of 1 girl and 1 boy. 2 pupils. Alright. And what does that mean, Charlie? Okay. How many girls do I have to choose from? Yeah. Alright. And 1 boy? 61. Is that alright? Also wants the probability. So just give me a second with that. So that's 60. Okay. How many different ways is there of choosing the 2 prefects without any restrictions? Can anybody tell me? 16 students choose 2. It's going to be a reasonably large number. 120 ways. So what do we reckon is the probability? 60 divided by 120, which is a half. Okay. Pause here. Next question. I want specifically 1 girl who is left-handed and a boy who's left-handed. Okay, that sort of restricts our choices a little bit. So, how many girls are left-handed? 3. How many boys are left-handed? And that is 3c1 multiplied by 3, which is 3. 3 divided by 120 is 1 in 40. You all good? Okay. Now, at least 1 pupil who is, 2 left-handed pupils. How many left-handed pupils do we have?
4.
And you have to choose 2 of them. And you get 6. And then 6 divided by 120 is 1 out of 20. Okay. At least 1 pupil who is left-handed. So both of them can be left-handed, 1 of them can be left-handed. So what's the trick we do for that? 1 take away the probability of no left-handers. Okay. So what's how many of them are not left-handed? 12. 12 of them aren't left-handed. How many of them do we have to choose? 2. What's 12c2? Anybody? Somebody really quickly, I haven't got my calculator on me here. 66. And 66 over 120. So it's 1 take away 66 over 120. And what do we get here? 54 over 120, which is 9 over 20. Alright. Let's move on. Good question though. Alright, next one, question 9. Looks reasonably easy. 3 dice, each numbered 1 to 6 are rolled. 1 dice is fair, the others are biased. Brilliant. So that for each of them, a 6 is twice as likely as any other score. Find the probability of rolling exactly 2 6s. Okay, have an idea. Red dice is fair. Green dice is biased. And the blue dice is also biased. Oh God. Are we happy enough with that? Okay. Now, what's the odd of rolling? How many do we need to roll here? Exactly 2 6s, is it? So here's what we're going to do. Not 6 and one other problem. Okay? See the way I coloured the bias dice different colours? It doesn't say that the dice are distinguishable from each other, does it? So I'm assuming the dice, you can't tell the difference between the dice. Is that okay? So no 6, 6, 6 is a different answer from. Sorry, no 6, 6, 6. So these are all the different permutations, alright? So it's addition. Alright. And it's 3 of them. So where I'm sort of torn between at the moment is I'm torn between, do I run the question where I can tell the difference between everything, or do I run the question where I can't tell the difference between the dice? That's where I'm sort of trying to figure out my route. So in situations in an exam like this, because it's only probability, I'd actually need to run both scenarios, and then I'd see which one I think. I'd run both scenarios and go, okay, which one do I think is better, or which one do I think at the end is good, alright? So let's run the scenario. Let's run the scenario that the fair one shows the 6. Okay, so we go 6, 6, no 6. Does that make sense? So scenario 1 is the fair dice shows a 6. So what can we say there? Anybody? 1/6, yeah. Now, now we have to do the. Okay. So in scenario 2, your odds of getting a 1 are, just say for argument's sake, 1. Your odds of getting a 2 is 1. Your odds of getting a 3 is 1. Your odds of getting a 4 is 1. Your odds of getting a 5 is 1. Your odds of getting a 6 is 2. Because it's twice as likely. Does that make sense? And when you add all them together, you're talking about 2 7ths, 1 7th, 1 7th. So that's where the 7th appears out. Does everybody get that? Because the 6 is twice as likely, the ratio is 1 is to 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 2. And then you have to add them all up together and you get 7ths. So the odds of getting a 6 is 2 7ths. Okay? So that'd be 1/6 by 2 7ths. And then the other one? Biased, but you don't want the 6. So what do you reckon? 5 7ths. Okay? Let's run scenario 2. What's scenario 2? Scenario 2 is actually the same thing, isn't it? Because this time you get 6 over here, but you get no 6 here. It's exactly the same probability, isn't it? But just in a different order. So it's going to be 1/6, 5 7ths, and 2 7ths. Okay? And the last one, this is the way I would have done it. I would have just pretended I could distinguish between all 3 dice, allocated them different colours, and ran through it that way. This is exactly the way I would have done it. And then finally, what ways are we doing it this time? No 6 in the fair dice, a 6 in the bias dice, and a 6 in the other bias dice. So what do we get then? Anybody? 5/6. And then in the bias dice 2/7, and yeah, and that's the answer they ran with in the solutions. Okay, so you should get an answer of add them all together. You should get an answer of 20/147. Is it? Is that what you did, Mick? Yeah. All right. So In this scenario, we treated all the dice that you could tell the difference of each dice, and we ran through all 3 scenarios individually, and that was the best way to do that. Don't assume the dice are, you can't tell the difference between the dice, okay? Alright guys, let's move on. Question 10, okay?
Sir?
Yeah.
Why don't you have to pull it over something else for the probability? So the other ones you have to pull it over.
Oh, it's already over it though.
Okay.
This is not a how many different ways it can happen method. Have an idea for you, okay? If you want to go down that route, I'm going to pause it